Hi, I'm R.D. Peters, and this video is going to be about how ancient people built Stonehenge, the tools and the methods they employed in building this great monument. And I hope you will bear with me. I do have vocal problems. I am a survivor of stage 4 tongue cancer, which has left me with something of a speech problem, and it's never stopped anyone from enjoying the information from Stephen Hawking, and I hope that you will also be able to understand me clearly enough. So I am in good company, and I will try to get this relayed to you in the most clear method as possible. But just bear with me, and we will get there. First, I would like to say that many experts over the centuries have tried to explain how the ancient peoples moved stone blocks, blue stones, weighing up to as much as 40 tons, 130 miles from their point of origin in a rock quarry to the final place at Salisbury, in the rolling hills of Salisbury, where it stands today. Theories have included that it was built by the Romans, that it was built by Merlin the magician, and in today's world, other fictional writers or theorists have included the theory of extraterrestrials. Now, I do know that this is a totally fictional account. Extraterrestrials, had they ever visited the Earth on the many occasions to build the great monuments such as Stonehenge, the pyramids, the Mayan temples, we would no doubt see other evidence, since spacecraft does require exotic metals and other materials that would have been left behind as evidence. And of course, I'm a fiction writer of 43 years, and I do know fiction when I see fiction. Here are a few fictional books that I've written. I have here a total of 18 fictional works. There's an old saying that it takes one to know one. And when I see fiction, I know fiction. And what I'm going to do, though, is take the actual materials that were available to man throughout history, from his earliest beginnings, and show how those were used in coordination with timber, wood materials, stones, to make this happen. And for example, I feel that man has been leaving out one important component, or one tool that man has had available all along in trying to explain these ancient mysteries. For example, in today's world, all inventions and all machines are said to be comprised of 6 known tools used by man throughout history. And those are the lever, incline plane, wedge, screw, pulley, wheel, and axle. However, I would like to say I think they left out one important tool, and that is rope. Rope is a combination of fibers and materials, anything from grass, weeds, tree bark to rawhide can be braided to make string, which can be woven together to make rope. Now, all the materials I'm using are going to be of the correct ratio, so that in doing this experiment and showing my model that it is the correct ratio for moving a stone weighing 40 tons. In this, I'm going to use string. It's a natural fiber. Since man in ancient times only had natural fibers to work with, this is a cotton string, 100% cotton, and it's of a diameter that would be equal to a 2-inch natural fiber rope. And a 2-inch natural fiber rope is rated capable of lifting 27,000 pounds, or 13.5 tons. Therefore, it's very strong, it's very lightweight, and it's able to be doubled to double its strength, and tripled, braided again to make it very, very strong. And its usage, it's very durable. And so, now I will be back in a moment and show all the components I'm going to use in developing this model. So I'll be right back. Okay, the first component I'm going to talk about would be this steel bar, which I'm going to use as the model stone material. It weighs exactly 20 pounds, where 1 pound equals 2 tons. So this was equal to a 40-ton stone. Here I've created an aggregate, and beneath that there's a wire mesh that prevents the materials from sinking down in it while I'm trying to display this model. And what I've done is I've gotten a scale here, put a rope around this steel block, and we're going to attach it, and I'm going to show the resistance against this aggregate. Now I can't really get a good clear picture with this camera, but this point right here equals 15 pounds. Now if ancient man tried to just drag this stone on a straight pull, it requires a great deal of effort to ever get it to move. And as it tries to move, it digs in further and further into the aggregate. We're up to 12 pounds, and the more I try to move it, the higher that goes. It's been going 15 pounds, 18 pounds. And actually, with this wire mesh below the aggregate, this object is actually moving with more ease than it would on a natural surface, because on a pull like this here, what happens is the weight wants to plow itself down into the ground, making the pull even more difficult as you put pressure on it here. So we went from here to about there on that display, showing it 18 pounds pull. That would almost be the equivalent of requiring 40 tons to pull that 40-ton block. Okay, so we can be fairly sure that ancient man didn't employ this method, because he would have stopped right in the beginning and there would have been very little forward progress to trying it this way. So I'll be back and show some components to a model that I've created that shows how we reduce the amount of drag to allow the stone to be moved forward. So I'll be back to explain those component parts. Here we have the component parts to a structure I'll put together in a moment. And in this model, I'm using 1/2-inch wooden dowel rods material. These are a couple of legs that's going to be used with a header that joins them at the top. These legs are 20 inches long, 1/2-inch thick dowel rod. All of this is 1/2 inch. 1/2 inch equals 1 foot. So this 20-inch rod equals 40 feet long. And then of course they have these headers on the top that will keep the bridge across them in place. To give you a better idea of what the size of these would have been, they're about the size of an average utility pole. And what I'm going to do is place this bridge in the top. These legs go to one side of this, and then we will walk this stone forward. And these will work much like crutches. And using leverage from these, with the ropes attached and manpower, it will move this 40-ton stone forward. Now what they would have done is built this a carriage similar to this. I know this is going to be an exact copy of what they would have done, but it's very similar. As you can see, this is a double thickness, or triple thickness if you count these skids. These are pinned together with wooden rods that equate to 3 inches in diameter. They would have bored holes through the logs here, which are slightly smaller than the pins. And these pins would have been hardened with the use of fire or dried, and then driven through the logs to hold them together that direction, and then also drilled and driven through another direction. And once these logs here, more than likely with green wood, would have shrunk onto these pins, making these extremely tight to where they could have never been taken out or loosened up. They would have had to have been drilled out They would not come loose on their own. And then on the bottom, there are two skids. This helps stabilize the stone and to move it forward. To place this carriage under the stone, they would have used levers. Dig down a little bit under here and put a stone under the lever. Begin to lever it up. Put stones underneath until they could work this underneath. Until they got it back here to the center. And balanced it. And using ropes, they would attach it to these. You can see there's an offset. Instead of just attaching it here to the center, they would wrap the ropes. That gives it more stability. Otherwise, if you just hook it here in the center, it wants to do this, which tips the stone forward into the ground or backward. And what I will do is be back with this put together and explain a little more about it at that time. Okay, now what we have here is the model completely put together. And you can see how the apparatus would have looked. What would have taken place is that these ropes here would have been manned by about 40 people on each rope. I've used these weights here to help hold it in place. You can see the stone has carriage beneath and how the rope is wrapped around in order to keep that from tipping. And over on this side you had ropes also with people manning those too. So when this team here of 80 people pulled this direction, this team would prevent the apparatus from falling all the way down. They would hold it in place until it was reset. And there would also have been a team of people at the bottom of these legs that after the move was made, then they would walk a leg, reset it, as these people tightened or loosened ropes as needed to walk the apparatus forward. At the top, it has the double beams. So this would equate to 2 feet thick of wood. The ropes are very close to the corner or where it's connected in order to put all the stress here to where it's the strongest instead of out here in the center where it's the weakest. Also, you can notice that these are movable joints that allows for quick action of set up and move forward, take it apart, and after the stone was at its destination, all these component parts could be wrapped up, taken apart and wrapped up pretty easily and carried back to the point of origin. Okay, I'm going to come back and have this set up again with the scale to show how, when making a move, we reduce the load to make this movement very possible for the number of men that I have indicated and for the type of materials used. We have the device set up now to pull, and I have this ruler at the bottom where a ½ inch equals 1 foot, and that will give us an idea of how many feet would be pulled at one time at this particular angle. However, they may have had the manpower to do it many more feet than what I'll display here. And at this time I will show that we're up to about 5 pounds. And it took a maximum of 7 pounds on that particular pull. And let's see if I can get a little more out of it. Of course, no, not at that point. We'll give it a try again and see what another pull would do. And but ruler indicates 4 inches, so that would have been an 8-foot pull. We'll try it again. I set it up again, loaded it in the exact spot it was on that first pull. And we'll give it another reading here. Okay. That pull there shows it's up to 14 inches. So in 2 pulls, we moved 40 tons, 28 feet. Now for the ancients to reset this, they would have did this one leg at a time while tension was kept on the ropes. With this being designed the way it is at the top, that allows those moves to be made very easily. And of course this may have worked better had I not left these weights attached to it, but I don't have enough arms and I have to use the weights to help me keep this upright. And with the skids on the bottom of this, that means there'd be very little wear and tear on that carriage. So even if they wore out the skids on the bottom, it would have been very easy to just bore out the existing pins, put 2 more rudders on it, drive the pins up through there again, it's ready to go. So that's my opinion on how ancient man moved heavy stones across the terrain. And also, this is an uneven aggregate I have here. By moving the legs in or out, a person is able to adjust for the different curvatures of the terrain. And of course, if you got too dramatic, they could always place a flat stone under one or the other to give it more of a level pull. so that the stone would move forward in a straight line. And hopefully this model puts insight out there on how it was actually done without the assistance from extraterrestrials. In summary, I would like to speak a little bit about science itself and why we cannot always find the solutions we need. In dealing with this problem, I feel that science has overlooked the value of rope, another tool that man had available in ancient times. And if we don't use all the information available to us, we cannot arrive at the right solution. In doing this experiment, I have found that it was more difficult, more challenging than I thought it would be. This is about my third or fourth attempt at putting it together and making it work. There are unknowns until you actually work on a project, and you find out that sometimes theory needs a little bit of help. Now, I didn't do anything here to cheat with the information. By using a natural fiber of cotton, I found out that it did take many practice pulls because it stretches. And it would continue to stretch until I got all the stretch out, and then I was able to make it work. And I'm sure ancient man ran into these same problems. And of course, he had the problems of enough people and the environment, the weather, and all that. However, in 2 pulls, I moved this 40-ton object 28 feet. And I estimate it would take about 20 minutes to set this up for each pull. So he was making about 90 feet per hour progress on a 10-hour day. That would be 900 feet, or about close to 1/5 of a mile. So if every 5 days he moved it a mile, it wouldn't take an extreme amount of time to move these stones, the 130 miles they were moved from the quarry to get them at the present location located in Salisbury. And it's been a very fun project, and I hope that you will email me and give me feedback on what you think. I have tried to look at it from all aspects and make it as realistic as possible with using the correct ratio for making this pull. And actually, the string I used easily moved this weight. So mankind may have used a smaller rope in making the pulls for the large stones. He may have had smaller rope and just doubled it, tripled it, whatever it took. So if you take a large group of men that work hard and go through the trial and error, it's easy to see that in a few days' time they've worked out the problems and be moving the stones. Unfortunately, much of our history is missing in action, and this is due to wars, peoples who had no written language. So all we're left with is the evidence of their works. And what we have to do is apply real science using logical models instead of trying to lead people down the road believing extraterrestrials solve mankind's problems of the past. The reality of that is it sells books, it makes great television shows, and everyone would love the idea that we are not alone in the universe. I'm sure we're not. But I'm also sure that we did not have help building our civilizations and our ancient monuments with the help from extraterrestrials. Now, I'm not done model making. In the future, I'll make more models about more ancient mysteries. And on this model here, I also see a very good possibility this is the same method that was used by the Egyptians to move the stones that they moved in building the pyramids. They did have other components used when making their pyramids. And I'm going to be working on those here in the near future and put together another video to show how stones were cut, worked, and designed by ancient man. And there are many, many tools and resources that ancient man had available that we merely overlook today because we haven't used them or employed these techniques perhaps for hundreds of years. So stay tuned, and I'll be back with more videos in the next few weeks. Thanks for watching.